So who am I and how did I get here? My name is Kelly. I'm Owen Wittrock's father, and I work at a company called SmartVault. Being professional, even Shadowbriar has its own logo. We get into things like this, and this is a logo that I borrowed from my company, that I borrowed from the marketing department. So it's my company, SmartVault, and this is our logo. So you'll see it's also up here on the slide down here in the bottom corner. It's on the first one. So what do I do at SmartVault? I run the engineering team, which at SmartVault includes both people who write code and people who maintain servers and systems. How did I get there? It's been a pretty long story, but as a teenager, my dad, he was a mathematician, and he was kind of interested in this new thing called computing, and he got an Atari 800. I like to play video games on it, but he also kind of got me to write some code on it, so I wrote some basic code on it. And I thought that was pretty neat, that was interesting. And then for years I didn't do anything with that. Many years later, I'm working on my mathematics degree. I have a bachelor's of science in mathematics. And I was taking a lot of math courses. They were a lot of fun. They were really interesting, very challenging. But I took a comp sci course. This is something that I had to do to fill the requirements. And I loved it. It was, for me, I loved the mathematics, but the comp sci stuff was much more interesting. And coding was like solving puzzles, and I love to solve puzzles. And as I was taking these classes, I thought, this is something I think I can do for the rest of my life. So I got pretty lucky that I tried something that new, something I wasn't that comfortable with, and it turned out that I really liked it. So I took a bunch more comp sci classes and I finished my education. So I graduated in 1993, and I've been working professionally since. So I've worked with technology in a whole bunch of different ways, from writing code to tech support. A long time ago, I worked in a tech support department and a test lab department, where we got to test CD-ROM drives, audio cards, displays, and the coolest part that my section focuses on was new video games. I got paid to play video games. It was very fun. Very a lot of work, very challenging, but it was a lot of fun. And as I progressed in my career, I moved into computer security and server management and so forth. That's where I worked in engineering teams, I've worked on IT teams, and development teams where they're actually writing code. So 20 years later, here I am. So what's it like for me today? I'd like to point out some really cool things that, because of the choices that I've made and the interests that I have, I'm surrounded by brilliant people. Extremely creative people. They're all very unique. They are different nationalities, different races, different religions. Everything about them is completely different, which is great for me because I don't want to hang out with a whole bunch of people that are just like me. I want to hang out with a bunch of people that are different than me, so I get to learn about different cultures and different ways to think about things. I would like to point out that, how does something magically appear? You guys are running programs right here. You're running the Windows operating system, right? That's the thing where you click start, and then on that that's a program. And then in that program, you're running your application. How does that happen? So what I want to describe to you was called, this is how you deliver the idea. It's the software development lifecycle. And this touches the thing all the way from idea, all the way to supporting it. So the first thing you got to do is you have an idea. You have to build a design around it. We can't just take an idea and just start hacking away and throwing some code around. We'll probably just make a little bit of a mess. So what we'll do is we'll get together with a variety of people with different skill sets and so forth, and we'll actually go through a design process and build a design about it. So we can understand that what are the inputs and what are the outputs? What's the user interface look like? What are the use cases for the customer? How are they going to use this thing? Once we have a design, you'll see here the next step is we're going to build. Now we're writing code. This is the fun part for the developers. They get to geek out. They get to get into all these technologies, whether it's databases or encryption, these types of things, and they get to build it. So we built something. Great. Can we just sell something we built? No, we got to make sure it works properly. So then it goes through a testing phase where people who focus on their job is to break things all day long. They break things. They try to find problems in the code. Maybe somebody was expecting numbers to come in and didn't think anybody would ever type letters. Well, what if that crashed the program? What if that program was something controlling your car? that could end very badly. So testers are there to try to find things that don't work properly and to also make sure that it behaves well when unexpected things happen. And then we have to document it. We can't just put something out in the field. People have to learn how to use programs and then deliver. We can build something and nobody ever gets it, but unless we deliver it, nobody's going to get to use it. So in this modern day and age, we'll do stuff like put it in the Apple Store. Anybody ever been to the Apple Store? Yeah? Download the program on an iPad or iPod? That's the delivery mechanism for an Apple application. There are other stores. There are stores you go and actually buy boxes and they have CDs and stuff in them. Well, there's a process that you have to go through to take the thing that you built, tested, and documented, and get it all packaged up and get it delivered into that marketplace. Okay? Maybe it's Best Buy, maybe it's Apple. You like Best Buy? They have a lot of stuff. Yeah. Amazon, that's a pretty good one. Yeah. So that's great. We've built something, we've delivered it, we got people using it. Are we done with it? No. That's when the story just begins. You have to maintain something. There's going to be things that happen in the field that you never thought about. Like we talked about, it's supposed to get numbers, and somebody puts in letters. Oh geez, we didn't think about that. They're in the design or test phases, so we got a program in the field that has a bug. It's blowing up. So we're going to have to issue a fix for that thing. And also, a lot of times you release the first version of something, you had an idea of doing 3 or 4 things, but then somebody else comes up with this great idea. It's like, well, what if it did this 5th thing? That would be fabulous. So then we go through a revision process and we add that 5th thing into it and make it even more powerful to a customer. You guys ever downloaded, say, one of your iOS games? You get a new version of it, and it's got like new characters and that type of stuff? Yeah? That's what that is. That's in their amendment mode, and they're adding and enhancing and improving things. So what I want you to get here is that coding is powerful, and without coding, none of this other stuff exists. But coding alone does not produce great things. It takes different perspectives on it, different viewpoints, and different skill sets. So I talked about my company, SmartVault. What the heck is this thing, SmartVault? Well, SmartVault is a SaaS company. That's a big buzzword today, SaaS, software as a service. What that means is we're an internet application. You ever heard people refer to clouds, and they're not talking about the ones in the sky? Cloud is just another name for internet. Okay? So what we do is we provide internet services for banking, tax, accounting documents. So this is stuff that we kind of got to protect, right? You can't have your accounting and your banking information sitting out on your coffee table. That's private information. You've got to secure it. Well, now that it's in the internet, anybody with a computer and an internet connection can try to get to it. So we have to protect it. Everything must be secure at every point. So what are some of the technologies that I get to work with? My shop works with Windows, Unix. Unix is it's a really old form of an operating system. You guys probably aren't running it here, but I guarantee you're going to run into it in your lifetimes. It's very powerful. It's kind of the grandfather of operating systems. MySQL, which is database. You got a whole bunch of data. You got to put it together. You got to store it somewhere. We have a database table that has over 350 million rows in it. 350 million entries. How do you deal with that? So we have to make sure that it's secure, reliable, and that we don't lose the data. And a newer technology, which is pretty cool, RabbitMQ, which is a message bus technology that lets you handle complex workflows that will scale to the level of the internet. So think about the internet. Your computer can do so much with your computer and create so much activity. But now put it on the internet, and there could be 50,000 computers all simultaneously at the same time, all communicating with your program. Your program has to be able to handle that scale, or at least deny it gracefully, or you're going to crash your application. So we use cool things like RabbitMQ and Couchbase. So I talked about secure. Communication is critical. We have to have a secure communication. Remember I talked about we're dealing with these really sensitive documents here. And you've got, say, a document on your computer there that is, hey, so maybe it's all your banking information. Maybe your bank account numbers and passwords and all that stuff. Okay? That's on your computer. Well, you've got to communicate with our service in the cloud. We have to use secure communication. We can't just use regular HTTP protocol. We have to use HTTPS. So I made the S green because that means it's secure, it's encrypted. Okay? That means that the data coming from this computer to our service has been encrypted. And we use a really tough level encryption. We use 256-bit AES, which right now is really hard to crack. Every encryption method is crackable. So just make sure you guys get that. Everything can be cracked. It's a matter of how expensive do you make it? How hard do you make it? If the data is worth $5, is somebody going to spend $5 million worth of computing time to try to crack it? No, they're not. But if the data is worth $5 million, and it takes them $5 of investment to crack that, then they're going to try to crack it. So we use AES 256, and we also deal with credit cards. You guys familiar with credit cards? What happens if your mom or dad loses their wallet and their credit cards and stuff?
They won't pay for it.
They can't pay for stuff. What if somebody else gets those credit cards?
They will pay for it. They can.
So they can get that information and they deal with it. Well, now in our system, because we have to bill customers, we have a whole bunch of credit cards. We have thousands of credit card numbers in our systems. So we have to encrypt all that information as well, and we have to securely communicate to bill customers for the service. Does that make sense to you guys? So I saw a couple of hands come up and I was talking. Did you have a question?
My mom, somebody hacked into her account, and so she had to get another card number because they stole like $400.
Wow. That happens a lot in this day and age.
Can people hack into your account and steal a whole bunch of money and spend it and everything?
They can and they do. And the real challenge with this is that I don't have to be physically there. In other words, to steal this pencil, I have to be here to touch this pencil. But when the information's on the internet, I don't have to be there. I could be in Florida or I could be in Russia, and I could potentially access this.
So should I put your stuff on the internet?
Well, you have to. The world is so entrenched in internet computing that we have to put information in the internet. The thing is that what do you do with it? How do you treat your information? Do you treat it like it's important? Do you take care of it? And let me give you a couple of examples of taking care of your information. Complex passwords. If I put in a password that was just, say, PASSWORD, do you think people are going to figure that out?
Yeah.
Or what if I did 1, 2, 3, 4, 5?
Yeah.
They're going to figure that one out. What if I did a password that was...
How do you hack into that?
Well, let me get to that in a moment. I'll talk about that in just a little bit. So, good, strong passwords are very important. If you don't have good, strong passwords, then people are going to crack them. And this is the thing where the size of the password does matter. The longer your password is, the harder it is to crack it. Okay? So you want good, hard passwords. And you don't want to use your passwords. You don't whisper in your buddy's ear your password. That's private. You can make sure it's recorded somewhere safely in case somebody else needs to refer to it, but you got to keep it to yourself. So as I talked about, this is just a screenshot of the Smart Vault web portal. And when you get your picture just of this one, and this is where somebody will log in and they have a strong password that they have to use to get into this. And when they get into it, then they have access to all the banking, tax, and so forth information. I'm sorry?
And then they can, like, pretend it was you.
Well, if somebody got the password, then they can log in and they have access to it. Okay? So before we go on this, I want to talk about that thing you're talking about. The number one way where people are stealing information in this day and age is what's called phishing. And it's not spelled with an F, it's spelled with a PH. Phishing. What it is, where somebody sends you an email, as an example, they'll send you an email, and it looks like something from, say, Wells Fargo Bank. It says, you've lost your password, or even maybe you've won a prize. Click here. And when you click on it, it says, you need to log in and give me your password. So you go through a login, you put your username and your password in. Well, that actually wasn't Wells Fargo's page. What they did is they captured that information, sent it off to Wells Fargo, logged you in, and then sent you to that Wells Fargo page. So you have no idea that I just gave my username and password to somebody in Florida. and now I'm doing my banking stuff. And then what they're going to do then is they're going to come back around and they're going to either A, they're going to use that password directly, or there's even organizations where all they do is they collect password name pairs and they sell them. And then other people come in and they use those. Okay, so now imagine this scenario. For Wells Fargo, I use that username password. What if I use that same username password on everything that I have access to? What do they have now? Everything. So it's important for you to protect your passwords, make them complex, keep them to yourself, don't share them or type them in unless you know what you're doing with them, and make them unique.
Wait, so should you put a fake password?
Well, if you put a fake password in, you can put a fake password in when your login's going to fail. So that they're not going to give you information through that, but you're also not going to be able to log into the program you need to log into. That's the trick. So if you ever look at an internet browser, you have what's called the address bar. There's a whole bunch of gobbledygook in it. You look at that gobbledygook up there, you look at the very front part of it, and there's going to be a padlock. And if that padlock is not locked, and it's not green, don't use it. Look at the name. If it's supposed to be www.wellsfargo.com, it better say www.wellsfargo.com in an address bar. If it doesn't, then you shouldn't put your information in, because it could be somebody trying to attack you to fish.
What is it?
Okay. So a couple things I want to leave you guys with. Try something new. You just might love it. Remember I talked about I was this math major, and I just took this comp-sci course because I had to. Turned out I loved it. 23 years later, I'm still doing it. So try new things. You might find something you like. Anyone from anywhere can code. It doesn't matter what background, where you are, anyone can learn to write programs. Ms. Shahan is giving you a great experience and a great opportunity here to access and utilize your coding concepts in these programs. This is really cool. And I want you guys to understand, there's a lot more to computing than writing code. Remember we talked about you got to do the design, then you build, test, document, maintain, support. So there are entire organizations who do nothing but answer the telephone and help people with their questions or problems with it. Okay? All right, that's all I have for you guys today.
Say thank you, please.
Thank you.
Thank you for your time.